For the multi-point test, it measures air leakage and multiple induced pressures differences as described in section RA 3.8.7. Keep in mind that equipment can be automatically performed and multi-point tests may be used to perform the following steps. With the blower door fan sealed off and off, measure and record the pre-test baseline building pressure reading with respect to outside. This measurement shall be taken over a time averaging period of at least 10 seconds and shall have a resolution of 0.1 pascals. Now, this is the same step that we used in the original single point test before the blower door even started. Same principle. After you figure out the baseline pressure, then you will unseal the blower door fan. And you're going to turn on and adjust the fan to create an induced building pressure of approximately negative 60 pascals. We're negative 60 now. Keep in mind, up to this point, we've done negative 50. But here, for the multi-point test, we're doing negative 60. If a negative 60 pascal induced building pressure cannot be achieved because the blower door fan does not have sufficient flow capacity, then adjust the fan to achieve the highest induced building pressure possible and record what that is. You're going to measure and record using the same time averaging period as previously used. You're going to record the unadjusted building pressure without the baseline adjustment, the nominal fan flow without altitude or temperature correction, and then you're going to record the fan configuration, the model and serial number, and assure that the fan is being operated according to the manufacturer instructions as usual. You then are going to take and record a minimum of 7 additional unadjusted building pressure and nominal fan flow measurements at target induced pressures, which are approximately equally spaced between negative 60 pascals, or the highest achievable induced building pressure, and negative 14 pascals. In a very leaky buildings, the low end of this range may be reduced to as little as negative 4 pascal plus the absolute value of the baseline pressure. So you're going to be taking 7 different readings. At least. Then you're going to turn off and seal the blower door fan. And you're going to measure and record the post-test baseline building pressure reading with respect to the outside. This measurement shall be taken over the same time averaging period used in step 1 and shall have a resolution of 0.1 pascals. So in step 1, we talked about that the time averaging periods had to be at least 10 seconds. So whatever time averaging period you used in that step, you got to use the same time averaging period in this step. So if it was 10 seconds during step 1, it's going to be 10 seconds again during step 7. But regardless of what it is, they have to match. You then are going to estimate the precision of the test. You're going to enter the recorded test values, temperatures, and altitude into the software that can perform the necessary calculations in accordance with ASTM E779-10 Section 9. The software program shall calculate and report the corrected CFM50, the percent uncertainty in the corrected CFM50 at the 95% confidence level. And please keep in mind, to avoid a higher percentage of uncertainty than desired, the HERS rater may choose a larger time averaging period and start over as step 1. So if the reported uncertainty of the CFM50 is less than or equal to 10%, then the air tightness test shall be classified as a standard level of accuracy. If it's greater than 10%, the air tightness test shall be classified as a reduced level of accuracy. So for the multi-point test, you have to use an approved piece of software to do this. You cannot do it manually. So for the single point test, you calculate it manually. For the repeated single point test, you could either do it manually or use the piece of software. For the multi-point test, you have to use software. So for adjusting the CFM50 for tests with reduced level of accuracy, an adjustment shall be used to improve the probability that the tested building meets the required performance threshold. The adjusted CFM50 value shall be used when determining whether a building meets an air tightness threshold as stated on compliance forms. The adjusted CFM50 value shall not be used when calculating the air tightness of a retrofit building, when you're calculating an energy audit, or when assessing the air tightness of a group of buildings. So the adjusted CFM50 is equal to the extending factor times the corrected CFM50. Please don't confuse the adjusted CFM50 with the corrected CFM50. So far, everything that we calculated earlier was to calculate the corrected CFM50. Now we're calculating the adjusted CFM50. So for a single point test extending factor, the formula for that is 1 plus 0.1 times 50 divided by the induced pressure. And the induced pressure is basically the pressure that you were able to depressurize the house to. For the multi-point test extending factor, the formula is 1 plus percentage of uncertainty divided by 100. So for the single point test example, we have an induced building pressure of 50 and a corrected CFM of 1300. To figure out the extending factor for the single point test, we're going to be using 1 plus 0.1 times 50 divided by the induced pressure. So translating the formula is 1 plus 0.1 times 50. The induced pressure also being 50 is going to be 50 divided by 50, which is 1. So 1 plus 0.1 times 1 equals 1.1. So the single point test extending factor is 1.1. So the adjusted CFM50 for this scenario is going to be the extending factor times the corrected CFM50, which we calculated earlier. And that's going to be 1.1, the extending factor, times 1300, which is the corrected CFM50. So the adjusted CFM50 is 1430. For the multi-point test example, we have the percentage of uncertainty, which is 37, and the corrected CFM50, which is 1300 again. So to figure out the extending factor for this is going to be 1 plus the percentage of uncertainty divided by 100. So 1 plus 37 divided by 100, it's going to be 1.37. Because 37 divided by 100 gives you 0.37, so 1 plus 0.37 equals 1.37. So the multi-point test extending factor in this example is 1.37. And plug in the numbers further into the formula. So for the adjusted CFM50, I guess again you have the extending factor times the corrected CFM50. So it's going to be 1.37 for the extending factor times 1300, which is the corrected CFM50. So the adjusted CFM50 for a multi-point test with the same numbers, it's going to be 1781. Now we're going to be covering or talking about the forms associated with these tests. Keep in mind that the forms, again, are downloadable in paper copy just for practice purposes from the LMS and also from the California Energy Commission website. The CF3R EMV20 Alpha, it's used for the building envelope air leakage single point test with a manual meter. The CF3R EMV20 Bravo is used also for the air leakage test single point with an automatic meter. The CF3R EMV20 Charlie is used for the building envelope air leakage multi-point test air tightness test. The CF3R EMV20 Delta is used for the building envelope air leakage test for the repeated single point test, again with a manual meter. And the CF3R EMV20 Echo is used for the building envelope air leakage repeated single point test with an automatic meter. Again, if you have any questions, always feel free to get a hold of us through the messaging system, shoot us an email, or give us a call.